Hey, 皆さん、こんにちは。Zamurai Engineer です。So in this live stream, we're going to talk about the specification surrounding the Arduino Uno release 3, release number 3. So in any robotics project, we will start with the specifications of our hardware, particularly those of microcontroller or microprocessor. So this is the microcontroller and a powerful microcontroller even up to this age of multi memory and high-speed computers, because we are dealing with robotics with mechanical motion and outputs, or in this motion cannot be compared to electronic speed of electrons. Okay? So therefore, as the start, we have to look at the data sheets. Okay? So data sheets of Arduino Uno are 3. We have to open the data sheet on its description. So this is a perfect board, so controller board to those laboratory enthusiasts doing hobby of making integration of different parts and creating robotic application, mechatronic application. So we have to get familiar with electronics and coding. Because of that, we have to deal with the necessary objective knowledge of this board. This versatile microcontroller is equipped with a well-known 80 mega 328P and 80 mega 16U2 processor. This board will give you a great first experience within the world of Arduino. So, meaning to say, there are plenty of current Arduino systems right now. There are several types of Arduino right now, and if you are familiar with one, there's a big likelihood and chance that it would be easier for you in the future to get familiar with the other types. You may want to be familiar with this system, this type of platform, because of the low-cost products, low-cost controllers, low-cost boards, okay, I/O boards that could be expandable, modular, and I think this is very good starting point for any future serious programmer or robotic integrator to gain an experience. So target areas of this document is actually the industry, but anyway, like us, like many of us in the academy, in the students, academic sector, we are also interested, and later on guide our student for future career on robotics. Okay. So this document starts with features. So the following are the features of this microcontroller. So 80 mega 328, as we said, the P version of processor. Internal to this, it has several functionalities. Okay, so it has the memory. So ABR CPU at up to 16 megahertz speed. Okay, 32 kilobytes flash memory and 2 kilobyte SRAM with 1 kilobytes erasable EEPROM. Okay, electronically erasable. So meaning it is very easy to program and reprogram. Therefore, it could easily be used as the what if you want to try your coding skill. So learning the basics up to the advanced level is a very good platform. Security function on the same processor chip. It has a power on reset and brownout detection capability. So brownout detection to be able to turn off in the right way so that it will not crash at the middle of something critical. So peripherals, it has 2 by 8 bit timer counter, so with a dedicated period register and compare channels. Very important for a future programmer to know about this uh, capability. It has a 1 by 16 bit timer counter, so there are 2 by 8 bit timer counter and also one piece of 16 bit timer counter. Again with a dedicated period register, input capture and compare channels. Okay? And one piece USART with the fractional baud rate generator and startup frame detection. So this for communication function. Another one is one piece of controller peripheral serial peripheral interface SPI. So for serial type of communications. So controller, it could control. So we do not need a driver. Usually in our initial experience, each and every function as a driver and as a separate or dedicated IC or chip on board. So right now, within a single IC chip, there are a lot of functionalities included. So one piece of dual mode controller peripheral I2C and a very much welcome one piece analog comparator with a scalable representation. So it's not very hard to do in a electronics to get some op-amp, IC and connect it and let the IC perform comparator function. Okay, therefore you have to configure it in a particular setup so that it could deliver the functionality of a comparator, and therefore it could give us the most welcome analog signal. So very important in addition to usual digital type of signaling. Okay. So it also has a watchdog timer with a separate on-chip oscillator. The oscillator is of course separate, but the timer circuit is within the chip itself. So they call it watchdog timer. and therefore we only need to connect a resonator or oscillator component on the board. Okay. And it also has 6 PWM channels. It is an advanced type of communication or I/O, and could be directly connected to some outputs like stepper motor. It has an interrupt and wake up on pin change. This is a normal included function in any basic controller, particularly even microprocessor. There are interrupt. But in the same manner, previous or the older or the initial times of computers, we have a separate interrupt IC. Actually, there are two separate interrupt IC, and what I've experienced is actually those interrupt IC is as big as or in the same size as this current IC 80 mega 328. Imagine the improvement in manufacturing and production of digital IC chips. So without increasing the size and even actually decreasing the size, it adds more and more functionalities in one single unit or one single chip. Another functionality is the 80 mega, of course, 16U2 processor. So it has an 8-bit AVR RISC based microcontroller. So IRSC, okay, it's a little bit advanced. It is not the oldest era of computer components. So it's good. It's, maybe in a near future we'll have more and more development in this field, particularly if more and more increasing number of hobbyists, increasing number of young people going into this and using this to learn either hardware or software. Okay. Because of the demand, this would really change the dynamics and trend in the future market and technology along this line. So power is about 2.7 to 5.5 volts. Okay, so it's very natural level. So you will not like to give it an input of 2.7, but actually it can. You would like to give it about 3.5 and about 5. So that is maybe the ideal range, knowing the electronics characteristic. Another function here is the memory itself. It has a 16 KB ISP flash memory. It has a 512. So 512 EEPROM is a lot of programming. You can do a lot of programming, and in complement, it has also 512 bytes SRAM. So you can definitely use this for temporary memory usage. Okay? Because there are a lot of memory anyway on this. Okay, so 2 KB is RAM, okay, 1 KB EEPROM, so and 32 KB flash ROM, a lot memory. These are just the initial another segment of memory with the debug wire interface for on-chip debugging and programming. So those are the data specification of this controller. So we can now talk about for the details about each and every one of these. Okay, so we could start at the board itself. Okay, then we will proceed to the recommended operating conditions, functional overview, board operation, then the very important connector pin outs, the definition of pin or the map, so that we can easily control and program each and every function. Okay. Then afterwards, certifications and other things like FCC caution and documentation. So let's start with the board itself. The board could be applied in so many future application. It only depends upon our creativity where we can apply this board. The board is a flagship of Arduino. That's why it's called Uno. So in French language, in Italian language, it is first. So in our country, the same meaning exists. So regardless if you are new to this electronic board, it will use the Uno as a tool for educational purposes or could be for industry related tasks. If you are first and new to electronics, is your project. So coding in electronics, you can get started with the most used and recommended board. It is equipped with a well-known processor, 14 digital I/O pins, 6 analog outputs, so 14 plus 6, that is 20 USB connections, ICSP, header and reset button. So it is about 23 I/O. Okay. This board includes everything you will need for a great first experience. Okay. So for industry standard development board, using this in the industry, there are a range of companies already using this as the brain for their PLC. So we already know what are PLCs all about. Those are all programmable logic controllers. Okay, so we are programming the controllers. Okay, logic controllers. So usually it is also mainly digital I/Os, but it could be expandable to something with analog I/O, similar to this one. Okay. For educational purposes, this aspect of application has already been used for about 10 years. It is still widely used for various educational purposes and scientific projects. The board size standard and top quality performance makes it a great resource to capture real-time from sensors and to trigger complex laboratory equipment, to mention a few examples. Actually, in our country, the most important thing is for this to be low cost. And of course, since this is an Italian original product, could be expensive in our country. However, there are clones right now. Clones are not paid. They are clones in the same breadth and depth of what happened to the IBM and the generic computer industry of today. That is because this platform is an open architecture. Okay, so it is publicly known to the developers the documentation, the details of this platform. So unlike, for example, the philosophy being followed by Apple computer system. Okay, so this is an open source architecture. Okay, so open source meaning those source code could be seen by those interested developers. Okay, so and because of that, it's very easy for some up and coming and other countries electronic companies to make a clone and produce several clone of this, and because of that it increased in the number of application and increase in this usage, increase in the media attention, the increase in academic attention being given to this platform, uh, and the increase in the what development environment that make this hardware useful and easier to use. Okay, so it means a boom. There's a boom, and the competition is now making this very cost effective. So it means it doesn't really cost so much if you are looking for a cheaper alternative with almost the same capability. Okay, and and there are a lot of related products like starter kit, tinker kit, brush robot, and some other examples. Examples of a system or a programming environment. It depends on the requirement for particular uh, interested parties. Ratings, recommended operating conditions, negative 40 degrees Celsius to about 85 degrees Celsius. Okay. Note in extreme temperatures, EEPROM voltage regulator and crystal oscillator might not work as expected due to the extreme temperature condition. So of course, particularly crystal oscillator might oscillate faster, a little bit faster, and therefore would create a domino effect in the system, particularly if you already have a setup of a system as, for example, a solution to a problem. Okay? So you may need to modify for a particular high temperature range. So meaning to say, if you are working at, for example, 50 to 85, might be better to monitor the performance. But it is not usual, particularly in academe and school, university, college application, for small project by students and laboratory functions. It's not normal to have those type of temperature, so it would be just okay. Power consumption minimum 6 and maximum 20. So 6 to 20 volts for input. Okay. So maximum input voltage from USB connector, so 5.5 volts. And maximum power consumption, therefore actual amount of milliamps times voltage. So later on, using this maximum and per pin and per load basis of milliamp, in terms of milliamp, so we can just multiply and calculate the amount of power. So since this is a very small, composed of very limited number of components, so it doesn't really consume power as much. So it depends upon, of course, to the I/O, to the input out. I/O will consume power so much. That is given. That is a given. Okay, because we really need input and output. That is the requirement. This is just what the device that would deliver the desired sequence, procedure, and operation automatically. Functional overview, we have the board topology, top view, as you can see. Okay, so top view, we have the labels, X1, X2, those are the power jack and USB connector. So this is the power jack, this is the USB connector. And then PC1, PC2, so we have this one and this one. Those are capacitor. They are capacitor of about 25 volt SMD capacitor, about 470 WP. Okay. And what else? You have D1 and JZU4, J1, D1. So where's the D1? So we have the D3 here. So D1 here. The D1 is rectifier. So from the input, so you have the rectifier. Okay. So JZU4, this one is our microcontroller chip module. Okay. This is the 8P Mega 328P module. So how many pins? So 1, 2, 3, 4, 5, 6, 7 times 4, so 28 pins. This is the standard 28 pins. Then U1, U3, U5. So U3, U5, U1, U3, U5. They are regulator, 80 mega 16U2 module, and LMIC. Okay, so LMIC. Okay. U3 is the 80 mega 16U2 module. Okay, and this is the regulator. So it looks like a 3-pin transistor, okay, power transistor. So we have what else? Y1. Where is the Y1? F1 is the chip capacitor, high density. So chip capacitor. So what else? So ICSP and ICSP1. So pin header connector. So ICSP is one, ICSP, and then ICSP. So pin header connector through hole 6. Okay, so there are 6 of them. Okay, 1, 2, 3, 4, 5, 6. Those are the pins. Also for ICSP1. So another pin header connector through hole. Okay. So again, let's go further to the next topic, processor. So the main processor, again and again, we are saying this is 80 mega 328P running at up to 20 megahertz, but on the clock, so 16 megahertz. Okay. Most of the pins are connected to the external headers. However, some are reserved for internal communication with ISB, with USB bridge coprocessor. So that is reserved for that. Power 3. So we have the power 3, power in LD 0 going to the plus 5 volts, and then supplying 80 mega 16U to MU. So module, this is the module unit, and then that is about 261 milliamps. Okay, giving that kind of power, 5 volts times 261. So that is about how much? About 1.2 watts. Very small amount of power. And then 410 milliamps for the requirement of 80 mega 328 microprocessor. Okay, unit. And then very small requirement, 5.6 milliamps KPT SGC green LED. So that is for the green, and for yellow LED 8.7. So this very small, you can say this is 10 milliamps, this 10 milliamps, and still very small, almost negligible compared to these two. This one, so they are about 670. Okay, 670 plus this, so about 700. So 700 times 5, that is 3.5 watts. Okay, about 3.5 watts plus, therefore you have the supply of 3.3 volts. So therefore the incoming voltage will be converted to 5 volts and 3.3 volts. Okay, so if you are using USB as a source, so it will go in the op-amp, then produce positive 5 volts and also 3.3 volts. Okay, so those gray are the power I/O, and those red are the maximum current. So these are the maximum. So 3.5 watts is a maximum, So the green one are the voltage drain. So white box are components. So those are components. Okay. And the yellow are the conversion type. So op-amp type of conversion. Okay. So that means that is our power tree for the board operation. Getting started with the IDE. So this must be programmed. So therefore, the very popular way is to use the IDE. Okay, so you can install it or you can use the online version. So to connect to the Arduino Uno to your computer, so you'll need a micro B USB cable. So micro B USB cable. So it is really as it looks like you are connecting a cell phone to the laptop or computer. This also provides power to the board as indicated by the LED. Okay, if you use the USB cable. And how about web editor? All Arduino boards, including this one, work out of the box in the Arduino web editor by just installing a simple plugin. Okay. So web editor, the Arduino web editor is hosted online, therefore it will always be up to date with the latest features and support for all boards. Follow tree to start, so we have the reference below. Number 3, to start coding on the browser and upload your sketches onto your board. So you can use an online IDE or you can use an offline IDE. You can download and install this IDE. Okay. And getting started 4.3. So Arduino IoT Cloud. So all Arduino IoT enabled products supported on Arduino IoT Cloud, which allows you to log, graph, and analyze sensor data. Okay, trigger events and automate your home or business. Okay, so it is very much possible. IoT meaning Internet of Things. Okay, so we can have a control of something, usually building, usually home, usually businesses in a building, and using the capability of communicating through internet. So that's why it's called Internet of Things. And 4.4 sample sketches. Sketches meaning program. Okay, sketches for the Arduino can be found either in the examples menu in the Arduino IDE or the documentation section of Arduino Pro website. 4.5 online resources. So there are plenty of them because as already mentioned, it is an open source system, and therefore there are a lot of libraries that we can use. So you can explore the endless possibilities provided by checking exciting projects on Project Hub, the Arduino library references, and the online store where you will be able to complement your board with sensors, actuators, and many more. Very popular right now. So what about 4.6 board recovery? It is also having a built-in bootloader which allowed flashing the board via USB. Bootloader, in case sketch, locks up the processor and the board is not reachable anymore by USB. It is possible to enter bootloader mode by double tapping the reset button right after the power up. So power up, then double tap the reset button. So it will give the bootloader the control, and therefore it could be recovered. Okay, if some crash would happen. Okay, then connector pinouts, very important for us to know the definition of the pinouts. Okay, so it is the top view. So we have the microcontroller chip. Okay, this is 80 mega module. Okay, so the reset button. So we have the USB power jack. Okay, so we have the pinouts. So in this case, we have the analog output. So analog data available here. Okay, analog input. So with the converter ADC, analog to digital converter. So the analog input would be converted to digital type of signal. So here there are 6 of them. Okay. And on the other side we have what? D1 to D7. So those are the digital I/O that could be defined in the sketches. You can define in the sketches if you want to use it as input or output. Okay, but special definition we have TXRX for this neighboring pins, that is for serial communication. Okay, receive and transmit data. So D8 to D13, several definitions like SS for pin, B2, so MUSI, MISO, check. Okay, so for those upper pins. Okay, now you have the ground, then the analog reference. Okay, you have the analog reference because we know that we have a necessity for comparator application. So we have the reference voltage, reference signal there. So we have also SDA and SCL pins. And then next is the series of on the other side again, the series of pins. We have the 2 blocks which are the ground, easily just like this one. So they are the ground pins. We have the red, so we have the input. So you can use also this to give the board input voltage. However, it is better to use this input jack for supply voltage rather than this one, because this one doesn't have much of the protection, so voltage protection. So you need to be very sure if you would like to use this BN plus 5 volts plus 3.3 volts. Okay, so you need to be very accurate here. So these two are output voltages. If you have an input supply power here, or there, so there are 3 ways you can do it. So you will get an output 5 volts and output 3.3 volts. Okay. So reset pin, so internal reset. This is the external reset. So and IO reference. This is the analog reference, IO reference. No contact for the last pin. Okay. What about this limited? So for example, this one, this is the power. power LED. We have also this LED for receive data. This is for transmit data. Okay. And the other one for the built-in data which would respond to this check. So this pin number 13. Pin number 13 check. So it could easily be used to create a simple program that could check if the microcontroller is working properly. Okay. So those are the pinouts, and very important for us, the specific definition of those pinouts. So these are the pinouts. So analog J, digital J. So we will not do it one by one anymore because we already explained those on the previous section. Okay. So I will not explain this one by one. So we'll already explain this one. Mechanical information. So board outline, terms of dimension. So we have the length times width. So length is about 66 mm from the edge of the board to the center of the holes, okay, mounting holes. There are 4 mounting holes, 1, 2, 3, 4. So those 4 mounting holes. So I expand this size. It is not 1:1 because I blow it up so that we can see this on a little bit bigger screen. So 66 mm by 50 mm. So this is again from the edge to the center of the farthest mounting hole. So 50, meaning to say the reference axis is this one and this one. So those are the reference axis. Okay. So it is about, so if this is what? So if this is about what? How much is this? So this is actually 2.54 mm. So 2.54 mm. If this is 2.54 mm. Okay. So 2.54 mm, and you can add 2.54 mm here. So 68.5. So 68.5 or 68.6. That is the real length. 68.5 or 68.6. Then this one is 53.3. 53.3, 68.6 by 53.3. That is the actual dimension. Okay, so the mounting holes are with diameter 3.2 mm. So very small footprint. Okay, very small. So certification conforms to the EU, okay, and European Economic Area directives, and therefore quality for free movement within markets in those area. Okay. So therefore in our country there's not much there's not much obstacle and its distribution and use. 6.2 Declaration of Conformity to EU ROHS and rates 211. So these boards are in compliance with ROHS. So this is for the safe health and safety. Okay? So rates meaning registration, evaluation, authorization, and restriction of chemicals. So it conforms with those two. Okay? Regarding the use of certain hazardous substances, okay, and use of or restricted chemicals. Okay? So because of that, it has the following. It satisfies the following maximum limit in terms of what? Parts per million. Okay? So lead, okay, cadmium, mercury, these are what? Regulated chemical substances. Okay? So 6.3 conflict. As a global supplier of electronics, Arduino is aware of obligation with regards to laws and regulation regarding conflict minerals, especially with the Frank Wall Street Reform and Consumer Protection Act. So Arduino does not directly source or process conflict minerals such as tin, tantalum, tungsten, or gold. Conflict minerals are contained in our products in the form of solder or as a component in metal alloys. Part of our reasonable due diligence, Arduino has contacted component suppliers within our supply chain to verify their continued compliance with the regulation. So again, those are some regulation authority. So let's go to FCC caution. So FCC is for the government control of frequency. So it also stated here that it conforms to FCC RF radiation exposure. Okay. So this device may not cause harmful interference. This device must accept any interference received, including interference that may cause undesired operations. So IC ASR warning. This equipment should be installed and operated with minimum distance 20 cm between the radiator and your body. Okay, so 20 centimeter. So that is about 8 inches. Okay. So important operating temperature, negative 40 degrees, as already mentioned. So there's not much about it. Company information. It is an Italian company based in Monza, Italy. Andrea Appiani. Reference documentation. So there are several references here, mostly online links. So they have the project hub, very important, library reference, okay, online store. So those are very important reference documents. So that's about it. So in the next video, we will now talk about how to program this device. So programming, because we already know the details, the datasheet, the definition of pin, okay, and capability. So anyway, again, this is Dr. AP preaching engineering for nation building. Okay, see you on the program.